Ladies and gentlemen, welcome to the third Middle East IPv6 Enhanced Online Summit. I'm Toni, founder of Telecom Review Group and the CEO of Trace Media, and I will be the moderator of today's webinar. Following last year's success and the positive impact that the first two editions had, this year's edition entitled IPv6 Enhanced, Inspiring Innovation, Boosting Middle East Digitalization will focus on IPv6 policies and strategy in the Middle East and will allow industry experts to share their experience. This year also we have an impressive lineup of speakers who will share each from their own perspective and field of expertise the importance of IPv6 Enhanced. Our speakers for today are Dr. Bilal Jamus, Chief of Study Group Department, ITU TSB, Meshal Mheiri, Manager, Digital Policies Development, TDRA, Xiaohong, Project Manager, Information Technology and Internet, Roland Berger, Latif Ladid, Founder and President of IPv6 and Chair of ETSI ISG IPE, Omar Mansouri, Vice President, Technology Acceleration at Salat UAE, Ali Lawadi, Head of Service Enablement of Do, Carlson Rosenhoven, Managing Director and Co-Founder, EANTC AG. We will conclude the online summit with a poll at which we encourage you all to participate, and then we'll have a Q&A session. So please keep your question at the end of the session. Now, let's kick off the webinar with our first speaker for today, Dr. Bilal Jamus, Chief of Study Groups Department, ITU TSB, who will discuss the topic of IPv6 Enhanced for National Development. Dr. Bilal.
Thank you very much, Toni, and greetings to all colleagues everywhere around the world joining us today. And thank you for setting this up today, Toni, as IPv6 is one of the topics that we discussed at the WTDC, the World Telecommunication Development Conference that just concluded last week in Kigali, Rwanda, with close to 2,000 participants physically and online. And certainly the topic of IPv6 and the resolution from WTDC on this topic was among the many digitization development projects that were discussed, and the emphasis was put on the importance of the transition from IPv4 and IPv6, especially given the context in which we are today from a technology perspective. We are in a context where 5G deployment is accelerating. And as you know, 5G requires a significant number of addresses for the massive type connectivity to connect the Internet of Things devices. We're also in a context where the IPv4 address space has been depleted for the region and for the world. And so there is a need to go from v4 to v6. And we are in a context where there are 3 billion people still unconnected in the world. And they're rapidly moving towards connectivity. So if you look at the context we're in, there is a high demand, an increasing demand for IP addresses. At the same time, we have a total depletion almost of the v4 space around the world. And so this puts the IPv6 and IPv6 Enhanced at the forefront of policy making and then technology transition and capacity building. So in the ITU, we have a number of resolutions that are agreed by the 193 member states of the ITU with very strong participation from the private sector and other stakeholders. And at all levels, at the Plenipotentiary Conference in Dubai in 2018, we had a resolution on the importance of IPv6 deployment, Resolution 180 of the Plenipotentiary Conference. At WTSA, we have Resolution 64 for the standardization sector, and for the development sector, Resolution 67 that I just mentioned was updated in Kigali, Rwanda last week. So these are important instruments to make sure that the transition from v4 to v6 is at the highest level of policymakers around the world, ministers of ICTs, regulators of ICTs, really the decision makers at the government level that have the power to accelerate the transition from V4 to V6. And just to give you one example on that aspect of instrument, recently in Tunisia, for example, my home country, there was a very strong push from the Minister of ICT to transition quickly to V6. So in the window of 4 months, we went from a discussion among the 3 operators in the country to having V6 deployed and available. In addition, there was a circular issued by the Chief of Government, the Prime Minister's office, to make sure that all institutions in the government use IPv6 and transition to V6. So that's the policy aspect, which is an important first step. And then from the policy, then you have the technology, where the hardware and software needs to be enabled to deploy V6. And then the along with it, the hand by hand, is the human capacity to manage the network, an IPv6 network. So there is an important element of training and capacity building that ITU also provides to our member states who wish to do that transition. So we have an accompaniment project to help build the capacity along with our partners in the regional internet registries and other stakeholders to make sure that the engineers that used to deploy only IPv4 networks are now capable of deploying, managing, and running an IPv6 network. So maybe in terms of introduction, Toni, those are probably the 3 pillars that are critical for this IPv6 space: policy making, the availability of hardware and software, and the capacity building to ensure that we have the engineers ready to run an IPv6 network. Over to you. Thank you.
Thank you, Dr. Bilal. Now we will go for our next speaker for the day. Our next speaker is Meshal Mheiri, Manager Digital Policies Development, TDRA, who will highlight UAE government IPv6 policies and strategy. Meshal, for you, please.
Thank you so much, Mr. Toni. So distinguished guests, ladies and gentlemen, greeting from the Telecommunication and Digital Government Authority. As introduced by Mr. Toni, my name is Meshal Mheiri. I am the Manager of Digital Policies Development within TDRA UAE. First of all, I would like to thank Mr. Toni for his invitation and his team in the background for the great support. I'm glad actually to be part of the 3rd edition of the IPv6 Enhanced Online Summit. And I would like to take you through a quick visuals that will illustrate actually the current situation of IPv6 worldwide, within the region and in the country. So these are a few points that I would like to start with as a start up for this presentation here. We are not talking about the future, we are talking about the present. The reason why during the last few years, we have seen a lot of RFCs that have been published for almost 20 years earlier. And this is just a sample of a few of the RFCs which have been published. And there are some more additional which might be related to the ICMP, related to DNS and so on. So the message here is that we are not looking at something which will be introduced for the future. We are actually using it, and we are in the time where we need to enhance the adoption of IPv6 within our country, with the support of different countries worldwide to achieve the highest adoption rate between all the countries. Another point which I would like to start my presentation with is that we need to understand that the IPv6 will identify unique devices with a specific IP address, where it will resolve the NATing issue within the IPv4 that we are currently facing. to eliminate the huge need of IPs to support the huge number of new devices coming from the emerging technologies. It will simplify actually and enhance the efficiency of routing. It will increase the security features within the overall ecosystem of connecting devices and transition of the data in the internet cloud. So from a high level, what are the main facts that all of us need to understand in regards to the internet protocol? Internet protocol, it supports actually all the devices to connect to the internet. As mentioned by Dr. Bilal earlier, we are already knowing that the IPv4 is fully consumed. And this is not since like a year or 2 years. It's since almost 2011. And it was one of the hot topics since that year. The IPv4 was providing the 3.7 billion addresses, where as of today, almost 23 billion devices are connected. The need of enhancing or the increase of the devices connected actually derived the introduction of IPv6. This is a view from Google as a content provider here, where it shows the current status of the adoption rate worldwide. You can see here on the top right, and this percentage was captured on the 17th of June, that the overall adoption rate of IPv6 was almost 39.52%. On the bottom of the slide, you can see 5 different countries, and they are at the top level of adopting the IPv6 worldwide. During the record of these kind of adoption rate in the last few months, we have noticed actually that some of the top countries leading was India. Nowadays, we can see France have jumped in a dramatic way. So the percentages are differing on a daily basis, if not on a longer basis as well. If we have a look more focus on our region, the Middle East, we can categorize the adoption rate as either low or mid to high adoption percentages here. If we include within this map, if we include India, so it's the first in this region, followed by Saudi Arabia, as well as the United Arab Emirates. So what's the current status of IPv6 within the United Arab Emirates? We have noticed a steady growth in adoption rate from the Q4 of 2021. The reason of this steady growth is the solid and new infrastructure that support the future needs of adopting IPv6. But on the other side, we have recognized that there is a low utilization in terms of the assigned and allocated subnets of IPv6 versus the used IPv6 among the organizations and entities. And it was not exceeding actually the 10%. On the bottom of this slide, you can see 3 different content providers, where we are highlighting here the percentages of adoption within the United Arab Emirates of IPv6. So we can see here that in Akamai we are having the 42.2%, in Google 45%, in Epinic 42.5%. There is an information which I would like to add here, and that during the last year up to the moment, we have jumped almost 10 points or 10 percentages from the one which is presented on this slide. So there are some risks which we need to identify here. Risk of not going to IPv6 and stay with IPv4. There will be an increased cost due to the legacy systems which are having and moving toward the new infrastructure required for IPv6, which will cause actually difficulty for transformation and the support of having smart city concepts within the country, which it will hinder actually these kind of projects. It will also slow down the investigation procedures, and it will add obstacles within the cyber security space. The decrease of performance of services will be a major cause once the complex technologies are being on place. The investment attractiveness of the country will be low due to the giant organizations requirements to set up their organizations, enabling their technologies within a country. Most of the organizations, and maybe we can specify the ISP sector from an infrastructure perspective, consider these challenges to transit from IPv4 to IPv6. One of them is the hardware lifecycle. When we say hardware lifecycle, is that in case, let's assume that we have a set of devices that have been installed like 3 to 5 years ago. These devices are expected to be out of life or out of service in the next 5 to 10 years. So most of the practices are to keep these devices till it's out of date and start planning for the replacement. But due to the quick changes, these kind of thoughts need to be changed actually. The second challenge that is considered as maybe a slower or a key stopper for implementing IPv6 from a financial perspective is the high cost and the long-term financial return. There is a challenge which most of the audience for sure is agreeing on, is the technical expertise and the awareness part. So if we consider them as a capacity building area, yes, we need the technical people to have the appropriate training materials, the appropriate procedures actually to do the shifting, to avoid any kind of disruption on the quality of services provided to end customers, as well as end customers. And customers need to understand the benefits of transforming their home networks, business networks into IPv6 enabled environment. So the importance that IPv6 derived the UAE to initiate its strategy since 2009, maybe earlier, the need actually of having more IPs. The UAE have almost 4 million IPs assigned, where it require actually 35 million. There is an increased demand for implementing the new technologies like IoT, like 5G, and the other emerging technologies. Sustainable development also was one of the major aspects that drive the UAE to initiate the IPv6 transformation project. The importance of the new features that will support the cybersecurity also was one of the areas which derive the kickoff of transformation to the IPv6, as well as considering the UAE as a hub for SMEs and giant organizations, especially from a technology perspective. These were the main reasons of the UAE started implementing the IPv6. So in a very high level, we have planned it as the follow. The subnet allocation was made as an initial stage, and then the operators start looking on the network upgrade from a network component, hardware upgrade, as well as a software upgrade. The architecture design was reviewed to ensure supporting the IPv6 a new requirement, as well as ensuring the seamless experience between customers who are still using IPv4 as well as IPv6 from a customer perspective and from a content provider perspective. A firmware upgrade was one of the main areas that the service providers worked on, from a customer premise equipment toward the handset software update and so on. It was followed actually with a pilot traffic test, where to ensure that the service assurance and the quality of services are not interrupted. And after completing the pilot test, the devices which were enabled actually with IPv6 started communicating to each other on the new identified protocol. So currently, what is going on within our deployment plan? So we have more automated IPv6 parameters to support any kind of new customers, being from a fixed network, from a mobile network, to be registered with the parameters required to have traffic initiated from their end devices in the IPv6 cloud. A more focus on the legacy systems to ensure that no more complex infrastructures are in a place, and to have more smooth transformation toward the future of IPv6 in the country. So we have a lot of initiatives that we are working on internally for the from a training perspective, from an awareness perspective of the technical staff, as well as the society within the United Arab Emirates. We are in a track of the adoption increment rate of the United Arab Emirates, as well as the progress of the ISPs on a monthly basis. As highlighted earlier, we have started the broadband IPv6 enablement in 2009 and the mobile network in 2018. One of the major points that I would like to highlight here, the adoption of IPv6, it's not an individual work. I mean, it's not an entity that can do everything from a country perspective. It's a joint venture. So from our end, we have our authority as TDRA with the support of our infrastructure owner, I mean, Etisalat and Do. We are orchestrating actually the project, and the expertise within both the operators are working on a great basis to do these kind of enhancement on a daily basis, which we can figure out from the statistics of the CDN providers. So just to summarize this slide, any country that would like to adopt the IPv6, they need to have a community from regulator perspective, from an infrastructure perspective, from CDN providers, as well as the manufacturers, and not forgetting the end users. It's a complete chain that need to be connected with. So for example, we have approached all of the manufacturers, from a customer premise equipment, from a data center network devices, to ensure that they are enabling the IPv6 features within their devices. We were in touch with most of the mobile manufacturers to ensure that all the softwares enabled on the devices currently used by end users, as well as any new introduced devices. So these are some takeaways which we would like to share with all the audiences here. So raising awareness and training is a real important point. Without the awareness of end users, without training the specialized team members who are implementing the changes on the network side, it won't be beneficial. There should be tools and instructions. We need to develop and publish special tools and guidelines to facilitate the transformation process for entities. So it will be more standardized, it will be more understandable to all the entities within a country. We need to have a standard specification from a hardware perspective, from software perspective. And the last point, which I personally consider as a very important part, the international cooperation. It won't be beneficial if one country is trying all its best from a technical perspective to increase the adoption rate if some other countries are not doing the same, if the, let's say, website providers, system providers, the new content providers are not enabling actually traffic from their side of IPv6. So that's the end. Thank you so much, and hopefully you enjoyed the material and the presentation.
Thank you, Meshal, TDRA, for this all this really very helpful details you already did. Now we'll go to our next speaker, Xiaohong Yang, Project Manager, Information Technology and Internet. Dr. Will, mute. Sorry. He joined and he didn't know that he's sorry. I'm really apologizing for in his behalf. Okay, so now our next speaker, Xiaohong Yang, Project Manager, Information Technology and Internet, Roland Berger, who will explain how to embrace the IPv6 to unleash enormous value. Please go ahead.
Hello, everybody. Good morning. I'm Yang Xiaohong from Roland Berger, and I'm honored to be here today to share with you on the sorry. Can everybody see my screen?
Yes,
okay.
Yes, that's good.
I'm honored to be here today to share with you our insights on the value of IPv6 and IPv6 Enhanced. So without further ado, let's jump right into the topic. We just discussed the technology benefits and the necessity of transition to IPv6. Meanwhile, we must realize that IPv6 and IPv6 Enhanced would bring us enormous social and economic benefits. For example, first of all, it will bring sustainable economic growth. It will drive innovation and entrepreneurship, as IPv6 is key to the essence of the free and open internet. It would empower digital economy transformation. IPv6 Enhanced is the foundation of digital technologies. It will sustain economic growth in post-pandemic era. It supports remote and unmanned tech. Secondly, IPv6 and IPv6 Enhanced will boost the development of science and technology. IPE promotes IoT efficiency. It will support mass connections, node efficiency, and service quality. IPE would also support data collection for AI applications, and it will facilitate blockchain development. It could support mass connections, high throughput, and concurrent processing. Third, IPv6 and IPv6 Enhanced would improve people's general well-being. It will have enormous social values. IPE enable applications such as smart homes, smart vehicle, and better entertainment. IPE would also support social governance. It will have positive effect on personal and national security. Also on digital equality, it could balance the digital power and provide equal access for all. So IPv6 deployment will positively affect virtually every industry sector. So we conducted an analysis based on our model and expert input. We estimate that the potential global value created across multiple industry sectors enabled by IPv6 and IPE could reach about 10.8 trillion in 2030. This would represent about 4.8 of all global real output in 2030. Let's take an example. For example, besides the obvious information and communication sector, public service and utilities will benefit from the efficiency improvement via semi-mandated NAT removal from government, also from value created by new infrastructure and new business models development based on IoT, such as smart cities. And in total, it would gain like about 4.8 of its industry total value. And if we break down the different perspective of value created, we can easily see that data security reduction and efficiency improvement based on migration from IPv4 to IPv6 have certain but limited benefits. It is IPv6 Enhanced construct of new connections and empowering in-depth innovation applications that will garner almost 80% of the total sales enablement and lead the development of the industry with upgrades and reforms. For example, in the manufacturing sector, IPv6 enable via empowering innovation thanks to application scenarios and business models such as Industry 4.0, smart manufacturing, 5G factories, etc. It will lead to about 3.6 trillion value created. And here, last year, in collaboration with Huawei, we constructed an IPv6 index, and this is the evaluation of the 2020 result to provide country-level measurement of IPv6 deployment status. We measured 79 countries' IPv6 deployment at 4 stages: at the planning perspective, at network deployment perspective, at content deployment perspective, and finally with the end user capability to generate these results. And the country was segmented into 3 groups, that is the front runners, the adopters, and the starters. And if we take a deep look into the result, if we look at the sub-indicator, which is the planning, network, content, and user, we can see that difference between 3 groups are mainly driven by discrepancies at the network and user level. This shows the importance of IPv6 deployment in communication networks and user capabilities to access the internet through IPv6. The reason that IPv6 readiness at the network level is crucial is that it provides a fundamental basis for IPv6 deployment across the internet. It enables applications and content to be IPv6 ready. Network service providers' implementation of IPv6 is critical to enable IPv6 technology diffusion from the supply side. On the other hand, IPv6 adoption and capabilities on the user side will create demand-side drivers that together with the supply-side factor will create a positive loop that boosts IPv6 deployment. Typical levers to increase user-side demand include the widespread use of IPv6 enabled consumer devices and user awareness on IPv6 benefits. And furthermore, IPv6 deployment for sure, it will have a positive impact on GDP growth. We conducted analysis and find out that for about every 10% increase in our IPv6 index, it will result in an expected about 0.4 increase in GDP. And let's look at a few examples. So government actions have strong effect on the overall adoption of IPv6 and IPve technology. Through our analysis on the policies of different countries, we find that front-runner governments display very strong policy implementation, wilder range of enact policy, and more frequent policy updates. For example, we have Germany, which is a front-runner country here. And German IPv6 Council was established in 2007, and National IPv6 Action Plan was introduced in 2009, and IPv6 Transition Guide of the Public Administration was introduced in 2013 to facilitate public procurement of IPv6 ready production. In addition, a series of guidelines had been published during the 2010 and 2013 that promote IPv6 at both their federal and state level. Another front-runner example is United States. National IPv6 Council, their National IPv6 Council was established in 2004, and their National IPv6 Strategic Roadmap and R&D Roadmap was released in 2008, and the government announced the IPv6 implementation schedule in 2011, aiming for native IPv6 mode by 2015. The IPv6 Adoption Act in 2015 provided the necessary push for ISPs to move to IPv6, and by 2019, these goals, the successful adoptions was achieved. And as Meshal just introduced the situation of UAE, I won't further elaborate on that. And for Saudi Arabia is another adopter country. The National IPv6 Task Force was formed by the Communication and Information Technology Commission, so CITC, in 2008. And in 2018, the task force brings in service providers as core participants with more regular meetings, and IPv6 adoption progress was continued to report their IPv6 adoption progress. And since 2019, regular KPI reporting has been adopted to track and maintain IPv6 deployment effort. As we can see, government policy plays a really important role in the further adoption of IPv6. So what kind of policies should government adopt to accelerate the whole process? After studies of countries around the world, we find that a good corresponding policy, not one policy, but policy package should include these 5 perspectives. First, the overall strategy is of course very important. Since the deployment of IPv6 is a long-term transition plan and highly requires cooperation between shareholders, the development of IPv6 is highly dependent on the guidance or the requirement of government policies. So a strong multi-dimensional high-frequency IPv6 deployment policy helps IPv6 quickly penetrate various industries and organizations. And of course, government could use various levers to mandate and encourage IPv6 adoption for both public and private sectors. For example, the government could mandate IPv6 only readiness in government procurement and to thus encourage the IPE adoption. And the government could also limit the use of the NAT CGN technologies and require telecom operators to be IPv6 compatible for 5G. And there's also all kinds of incentives and fundings that could accelerate the whole deployment. And furthermore, we cannot neglect that the skill development is also very significant. The IPv6 based tech industries and related applications will be vigorously developed in the future. This will require a greater pool of professionals. The government should launch training programs or incentive policies to ensure there will be adequate manpower for the future. And last but not least, the public awareness plays a key role in IPv6 deployment. As the end user of IPv6, the acceptance and awareness of the public will determine the penetration rate of IPv6. And overall, if we look at the different group of countries, the countries in the front runner segment of IPv6 adoption should take the next step towards the driving the IPE adoption, while countries in the adopters and in the starter groups, they could leverage the above mentioned policies to further encourage the deployment of IPv6. As for the starters, as IPv6 adoption at telecom operator is crucial to the overall deployment of countrywide deployment. We actually strongly recommend these countries in the starter groups. They should have policies that encourage telecom operators to adopt IPv6. So that's all in all. So let us move forward to take actions now and unleash these enormous value that IPv6 contains. Thank you so much.
Thank you, Xiaohong. Interesting also. Now we'll go for our next presentation, which is entitled IPE Industry, Consciousness and Alliance Development. Latif Ladid, founder and president of IPv6 Forum and chair of ETSI ISG IAP, who wasn't able to join us live, so he will share his insight pre-recording video. We'll play the video.
Hi, this is Latif Ladid from Luxembourg. I wish I could have been with you in person in this excellent event on IPv6. So I'll be addressing the IPE, so the IPv6 enhanced innovations that we've been working on from the ETSI group, from the ETSI ISG. So what are the drivers that we've been looking into? We had a closer look at all of them. I'm Latif Ladid from the IPv6 Forum, as well as the chair of the ETSI Enhanced Innovation ISG. So let me take you through some of the items that we have been discussing. So the first one is that we are obviously moving to IPv6 only into certain domains. So we had recent calls from the US government as well as from China. So I think in the next 5 years, this will be an important step in the last call into getting IPv6 done. And this will give us a certain network control with an end-to-end paradigm restored, which will facilitate far better configuration and maintenance of the networks. So this is really an important step in IPv6 deployment, as well as we are discussing during this conference in the next couple of days. Some new functionalities are really fundamental in making IPv6 delivering something quite unusual. One of them is SRv6, to get the end-to-end model properly deployed also at the network layer. And obviously, with IPv6 only internet, we will not have to carry 3 protocols at the same time. So IPv4 NAT, which is kind of steroids running the internet today. So CAPEX and OPEX are going to see a better future down the road. So if we look at the deployment so far, I think if we count China, which is not in the numbers of Google, with over 400 million users, which makes China the #1 country in the world deploying IPv6. So we are already at kind of 45%. This is end of 2021. But the call, as I mentioned earlier on, from the US to move to IPv6, especially the US government, and followed by the same call also from the Chinese government, and also from certain number of countries in Europe, such as France and the UK. But as well, the Berger has been doing certain number of workshops in order to get its stakeholders to move into the right direction as well. So if we look at where IPv6 is going to have a certain number of impacts, one will be on IoT, since the next level of IoT deployment will be to restore the two-way internet also for Internet of Things, so that these things can talk to each other and prepare decisions for us in order to make. So this is going to be an important innovation for IoT, especially in view of billions of these devices to be deployed. So you want them to be autonomic as such. So autonomicity in IoT will be a very important topic to research in and also deploy. And as of late, even back in April 2019, Adrian Scrays was the CTO of ETSI, as well as the founding secretary of 3GPP, has published at that time that it's time to move away from E164, so basically SIM card-based IoT, to IPv6. And some of the large ISPs, I know of the entity Docomo, which is deploying now IPv6 over IoT for IoT in their very large IoT network. So the impact on cloud computing is going to be also very important in view of the current discussions of how we can get data sovereignty and data transparency to be also taken into account. So the recent initiative of the European Commission, supported by the Germans and the French, but in the meantime, something like half the EU 27 are adopting the Gaia X. Gaia stands for Earth. So basically, it's earthbound data, which gives it a certain sovereignty. So we have already talked to the Germans, who are now mandating IPv6 for the first largest data cloud network in the world, and I think will be adopted around the planet as well. And the blockchain area as well, we're looking into it closely with some of the main founders of blockchain. We're not going to look at Bitcoin as such, but primarily for digital cash, I think that would be very important. But blockchain as such will be touching not only things like supply chain and so on, but it will be also touching 5G, IoT, as well as smart contracts, government networks, and such. So I think it's going to be probably after 3G deployments, creating the worldwide internet revolution. I think blockchain is going to add exactly the same type of inflection in order to kick in at least secure data. Then we have to make sure that the network is carrying this data also is going to be secure. So we've been working on some white papers, and I invite all of you to look at them. So looking at IPv6 and the various protocol innovations, as well as adding artificial intelligence. So this paper has been published already last year, but it combines the various use cases and the various best practices that we have identified across the world. So one of them obviously is how you can use SRv6, and I think this event is going to be focusing on this protocol, also combined with 5G slicing and so on. So there is a great potential in this area, to create something highly innovative. And we know of some of the countries, especially in some of the networks in Africa, are already deploying it across countries, showing some very innovative and even dramatic way of deploying new networks. This will apply for sure far better to greenfield environments, where you can deploy across the countries end-to-end service deployment. And will give you faster deployment than using, obviously, MPLS, although MPLS works very well. But I think, it's time now to move to something which is faster and obviously a lot cheaper. And as I mentioned earlier on, so artificial intelligence is going to do also its bit in making the provisioning a lot swifter and will satisfy the customers a lot more. Obviously, artificial intelligence is software-based, so it has to be very well tested because software always attracts bugs, as we know that from the past. So SRv6, and you will hear it from different speakers today, we'll look at its flexibility as well as simplifying the protocol and certain elasticity and scalability. So it's very important to see the seamless evolution in this area by maximizing the return on investment. And some of the papers that we are going to finally publish in the next couple of months will look at the 5G and the cloud area, especially by improving service experience. So we've been rattling, with NAT and CGN and so on. So that kind of stuff is part of the past. So moving to IPv6, you get at least some kind of high-speed train working on, but adding things like SRv6, you would be already flying on a plane. So that kind of business class experience is going to happen with these new internet IPv6 based protocols. So the transport networks industry will see this movement by looking at what we have done within the IT, but also looking at the best practices through real case scenarios and deployment scenarios within the ETSI IPE. You will see the move to IPv6 advanced deployment, especially using SRv6 and so on and so forth. So in the meantime, we have about 90 partners, so participants and members joining from operators, governments, as well as vendors, verticals, and a lot of research at the same time. And this from the 5 continents we have. So I have been very lucky to attract many of them working in a very harmonious way in this area. So the first release we have done is on the IPv6 Gap Analysis. So basically on the IPv6 innovation analysis, and we came to the conclusion that we are on the right track for this area. So just join the IPE, you'll be able to download these papers and spread them among your partners and stakeholders. So the next one, which is in the final review, is on the IPv6 5G transport using SRv6. So basically led by one of the ISPs in Europe, primarily in Luxembourg, which has been testing it. So it's a very important paper to read from a deployment study case. And the next one, which is very important, as I mentioned earlier on, written by an operator as well, which is China Telecom, looking at the data center and cloud network integration. So we expect this paper to be published by end of April. So I think by getting all of these stakeholders together, we come up with some very practical guides and some very deep use cases from the field, to see how these things happen in reality, which is, something very fundamental, to get the interoperability among the various vendors. So if you join us here, you'll be able to rub shoulders with these people. So in the meantime, let me wish you an excellent conference, and I wish next time to join you in person. Thank you. Bye-bye.
Thank you, Latif, for this presentation. Now we'll go to our next speaker, Omar Mansouri, Vice President Technology Acceleration at Salat UAE. Omar, it's you, please.
Yes, hi, good morning.
Good morning. Sorry, you're late. You didn't have time to welcome you before. Okay, so
Yeah, I'm glad to be here, participate in this event. As I stated, my name is Omar Mansouri. I'm head of Internet and IP core development. I've been lucky to participate in the deployment of IPv6 since maybe its beginning in Salat. So it would be maybe a good idea to share what we have gone through the deployment of IPv6 and what we have experienced. So people coming from different background and people who maybe are in the phase of deploying or phase on the beginning, maybe they can gain experience and learn from what we've gone through. So just to start, what we've done in our deployment, we started in 2009, and one of the main component we have to get is the IP addresses. The IP addresses we got, it was quite good, 34 billion/64, and this will be sufficient maybe for the maybe forever. The IP deployment, we started analyzing whatever we have in terms of components and networks, and these components, some of them are legacy, some of them are really are up to date, some of them needs to be updated. So we went and analyzed all of the components that support IPv6. We included the support if it requires, and then we went into actioning the deployment of IPv6. So in terms of deploying and upgrading the software, changing the hardware. So since Salat is like a brownfield, we had so many networks today in the network. We have GPON, business network, access, packet core, a lot of services, a lot of integration points. So we had to put all these measures into the deployment, and then we have to upgrade all these components to support IPv6. So when we talked about the IP allocation, it was really challenging since we have to build from scratch. What are the challenges that needs to be tackled during the deployment? What are the networks should be giving different subnets? What are the customers' requirements? So we had to put in consideration a lot of prerequisites that we had. And we divided the network into multiple things. Either it's internal network requirement, business network requirement, Etisalat infrastructure, telecom services, customers' LANs, international networks, businesses, mobiles, and future for allocation with the subnets that we require maybe in the coming era. So these should be put into consideration and made sure that they are properly allocated so you don't face issues in the future. So when we come to the deployment, to the actual deployment of the technologies, IPv6 was one of the critical areas is the protocols. So when we talk about protocols of the network, we talked about, for example, we had two different options, either to go with ISS or OSPF version 3. So we chose, for example, ISIS because we know ISIS has the built-in capability to support IPv6 from beginning. So we went with IPv6. And then we had to deploy this protocols in all the networks. Since Salat, as I said, big network, we had to do it in the IP core, in the internet, in the business, in the international, vice versa. And then some of the components that did not support the IPv6. So we had to do some tunneling protocols to support these capabilities. So we had to do 6PE, 6VPE. So we introduced the IPv6 even if the network itself did not support. And then we had to put the consideration of where to the security aspects. So since security is a big area that needs to be tackled, IPv4 we had a lot of capability. People they used to know what they used to do. So in terms of firewalls, access list, DPI, all of these capabilities should support the IPv6, and we had to make sure that the people are knowledgeable how to do the security aspect, because security is a very critical component of the whole deployment. If anything goes wrong, that your whole network will be jeopardized. And then we had to do the internal services like DNSs, radius, all of these capabilities, they had to support IPv6. And then we went to the network that they need to be supporting like GPON network and so on. if we look at the overall, so we had to do all these components end to end. So when we talk from the customer perspective until he reached to the content from the network. So we had three main areas, which is the broadband, fixed broadband services, and we had the mobile services, and we have the business services. Within each pillar here is multiple components, and these multiple components, they have to be enabled with IPv6 support. So if we talk about the fixed broadband services, we had the BNG, we had DHCP, Radius, DPI, wire filter, LI, billing, mediation, so many systems, they have to enable the IPv6 so we can have the service implemented end to end, which we consider it a very long journey. It sounds like a straightforward, but you have to make sure are those protocols supporting the system, supporting the capability, not only supporting the capability, you have to make sure that the users, they don't face issues during the deployment. And again, the same exercise was done in the mobile broadband services. When it comes to mobile, there are a lot of services that come from the access, RAN, and the IP packet core, UDC, HSS, and they have to support IPv6 end to end. When it comes even to the customers, they have to be CPE supporting as well. They have to be the handset supporting IPv6. And then the last thing is the business, for example, services. Normally, it gives the layer 2 VPNs and so on. So these kind of services, they don't need to enable IPv6 in the core, but they might use the tunneling. So you can extend the customer IP addresses to the end-to-end. So one of the big pain issues that we had previously is the CPE. The CPE, normally, a lot of customers, they have their own CPEs. And some of these CPEs, they don't support the IPv6. So how to tackle these kind of cases? Do you approach the customer to replace the CPEs? Do you offer them different kind of services though they can replace the CPEs? And we had reached to a good point that we were able to replace many CPEs that did not support IPv6. So today we have almost 80% of our CPEs supporting IPv6, and some of them they're called unmanaged. Those unmanaged, they need to be upgraded to support the IPv6. And again, when it comes to mobile, they had similar issues. So some of the handsets, they have to support IPv6, legacy IPv6 handset, they don't support. But mainly these days, most of the handsets, they support IPv6. So just as a highlighting, IPv6 was a big activity to us. We started 2009, and the actual implementation, when we went live, it was 2019. What I talked previously was the preparation of the real launch. It was 2019. 80% today, as I said earlier, is getting dual stack, IPv4, IPv6. So if the IPv6 did not exist, we'll go to IPv4 and vice versa. And as you see here, we have almost 45 and 50% already IPv6 in UAE, as highlighted by my colleague, Mr. Meshal from TDRA. And most of these CDNs coming as below, YouTube, Facebook, Instagram, these mainly the CDNs that they support the IPv6 capability. Some of them, they don't support. We are approaching different CDNs, they don't support. And I hope that with approaching these will increase our penetration in the network. The same was highlighted previously. We are, as Etisalat here, we are almost 50 according to Akamai, 44 according to Google, and we are almost 14, it varies, 14 in the global ranking, as UAE reaches 14. So I will highlight here some of the challenges that we went through while going through the journey. So enabling IPv6 in different layers, considering a brownfield deployment, not a greenfield. So you have to support a lot of areas to support the IPv6, replicating the experience that we had in IPv4, especially in the security part, where you have to make sure that no issues are happening, no holes are created. The knowledge-wise, the staff, they have to be very well trained for IPv6, so they can adopt the idea, and then for the future, they can consider deploying IPv6 in every area and consider implementing and even in the networks that they are handling. Again, the CPE, as I was highlighting, we have to upgrade the firmware. We have to do some fine tuning to support IPv6, and that was mainly both in the handset and the CPE and the handset of the mobile. And the CPE, again, we have to upgrade all the CPEs to support the IPv6 in the network. So what we see as a big challenges and what are the areas to increase the adoption of IPv6, we mainly focus on two things: increasing the awareness of the customers to adopt the IPv6 by replacing their CPE, because we cannot go and approach every individual and to replace their CPE. They have to adopt and acknowledge that they need to IPv6 to improve the capability and improve the performance of their connectivity. And IPv6, we've noticed that IPv6 has better performance than IPv4, almost for 20%. And the last part is the approaching CDNs. We've noticed many CDNs, they don't support IPv6 without mentioning the names, but a quite big amount of data coming from CDNs that they don't support IPv6. And we are approaching them to support the IPv6. I think I reached to the conclusion. Thank you so much.
Thank you, Omar, for showing us the journey of Etisalat in IPv6. It's really interesting. If you just stop screen. Now we will hear from Ali Lawadi, Head of Service Enablers at Do. Ali, it's yours, please.
Sure. Thank you very much, Toni, and thanks, of course, to the organizers of this event and Telecom Review and all behind this. We appreciate this opportunity to at least share our experience to the audience. So again, I'm Ali Al-Awadi. I'm responsible for the Technology Service Enablement Department in Do. And in my presentation, I'll give you a brief overview about our IPv6 enablement and our future prospect and how this fits into the overall ecosystem of the high ambitions when it comes to 5G and the different use cases that surround it. Now, of course, I mean, traditionally, if we look at traditionally, the main means of communication was essentially human to human. And as we can all witness, this is quickly shifting from human to human more into human to machine and machine to machine as well. And we talk about the fourth industrial revolution, we talk about IoT, autonomous driving and smart cities, and all of that is a different nature of communication that, although IPv4, I mean, for the past decades helped us get where we are, it's no longer, I would say, sufficient or enough to take us where we want to be. And that's why we're here to discuss about IPv6 and the endless possibilities that come with it. So again, why do we need IPv6? I'll touch base around this quickly, although my colleagues have gone through and highlighted the values and the benefits around it. But from a telecom point of view, of course, IPv4 is today a rare commodity. That's what I can say. And with IPv6, we're definitely removing that cap, removing that limitation in terms of numbers of the available resources that there are in terms of IPv4. And as my colleague, Mr. Meshal mentioned, IPv6 is not the future. It's actually today. There is this high necessity, high urgency of need for the IPv6 to be rolled out and adopted as soon as possible. Another benefit is, of course, optimized costs. There are less elements in the network, less network, let's say, touch points and hops, which will ultimately, of course, lead to improved experience and improved performance as well of the network and the user experience as well. Now, of course, there are certain, I would say, considerations that need to be taken into account, of course, when it comes to the evolution and the migration or the transition, if I could say, from IPv4 to IPv6. The most important aspect is, of course, to ensure maintaining a stable service during this evolution. Now, us as telecom operators, of course, like any other sectors, but of course, we pay extra attention to the service availability, the service quality, and that is part of our DNA. We have to be extra cautious when it comes to that. So whenever there's something new in the formula, we take our time, we take extra precautions to make sure there's minimal to no impact on our services, on our customer experience. Another important consideration, of course, is the handsets readiness in terms of the adoption of IPv6 and readiness to onboard IPv6 traffic. One more point that I noticed was mentioned across all the speakers today, the know-how and awareness. Very important point, very important to upskill the capabilities of the resources and bring awareness on the importance of IPv6. That will tremendously help accelerate this journey. And content provider also, as mentioned by my colleague Omar, the CDNs, the adoption of content, these are very important pillars that really define and needs to be well considered as part of this journey. Now, if we look at a very generic, let's say, topology of a mobile network, at the top of the screen, you'll notice the IPv4. And immediately, the first thing you will notice that there is no NATing required, of course, for the IPv6, and therefore the CGN is completely eliminated from this flow. And that's just one example of the improvements that come with IPv6, the simplicity that it will add to the already complex network of the mobile network. And that's definitely a plus sign, because at the end, it leads to reduced CapEx, it leads to reduced OpEx, less overhead on our operations resources to manage one extra node that is no longer required as part of IPv6. Now I'll show you also our growth when it comes to IPv6 provisioning for our customer base. Back in September 2021, we were actually at only 15%. And today in June, we have jumped to 46% of our customers who are provisioned with IPv6. Now, I must say that this is a joint effort. This is a joint collaboration. And of course, a lot of credit goes to our regulatory as well, because they are very keen to increase the percentages. They are paying a lot of attention and a lot of time and dedication and commitment in making this a successful journey. And that just shows you how important this is. And it adds extra level of commitment from us as operators, and pay extra attention on the importance of onboarding IPv6 and adopting it as part of our journey. And we're projecting, based on our projection by Q1, Q2 2023, we expect 100% of our customers to be fully provisioned with IPv6. Now, in terms of the sessions utilization, back in December 2021, we were only at 2%, and today we are at 24%, and it's exponentially rapidly actually growing in terms of percentage. And we're also keeping a very close eye on this. But again, there are different variables that play a role in this, especially when it comes to handsets and content as well, in terms of IPv6. Now, coming to the challenges, in terms of the high-level challenges that we went through as part of this journey. I mentioned earlier that's something that's very important to consider, developing the know-how and in terms of best practices and the technical capabilities of the staff, and the readiness and the collaboration that's needed with our partners and vendors. That plays a major role as part of this journey. Another important aspect, of course, is ensuring the readiness of the infrastructure and the platform and the network elements, and performing necessary upgrades and modernizations that are needed to accommodate the IPv6 journey. Testing and validation, again, as I mentioned, as a telecom operator, we have a very rigorous and very, let's say, intense set of testing and validations that we carry out. And as part of this journey towards IPv6, there was no exception. A lot of attention was paid to ensure a smooth transition with minimal to no impact. And the last 2 points, of course, very important aspects that we also went through as part of this journey is the ensuring the handsets readiness, and the TDRA played a major role in collaborating with the manufacturers and communication, and that was definitely a plus side that helped us improve and accelerate our adoption of IPv6. Now, the journey, of course, I mean, it doesn't end, and we're very much forward-looking. We already have and built the momentum of onboarding and accelerating the adoption of IPv6. But what next? And that's what Professor Latif mentioned, IPv6 plus IPv6 Enhanced. Now, if you read through or go through the benefits of IPv6 Enhanced, IPv6, the standard IPv6 becomes so legacy in the sense, although it's something that's the latest in terms of how it's replacing IPv4, but IPv6 Enhanced is that extra level of intelligence, let's say, extra level of automation and improved in performance that it brings on top of the IPv6 makes it a very attractive and very much as a next level of IPv6 evolution and improvements that it will bring to the ecosystem, especially when it comes to telecom operators. Now we could compare it. I mentioned it looks very much legacy, and you could compare it that the IPv6, the standard one, is like a congested highway. It will eventually get congested. But with IPv6 Enhanced, that's when we're going to introduce, or there will be introduction of smart routing and deterministic time of arrival, which will ultimately add more flexibility in path computing and better visibility when it comes from an operational point of view. Now, when it comes to use cases, now we started the first slide of the presentation with the fourth industrial revolution. Now we're going to end the slides with the different requirements and characteristics of communication and connectivity, if I could say, required for different use cases. Of course, there's different latency requirements, different bandwidth requirements, and different connections that are required as part of the different use cases. Now, we have always been focused on 5G, especially 5G SA, that it will introduce slicing. What that means is that you're going to have different dedicated set of quality of service, if I could say, for these different set of services. Now, what the IPv6 Enhanced will introduce is that it will ensure slicing happening at the IP transport network as well. And that will give us an end-to-end slicing from IP network all the way to the radio access, all the way towards these different use cases. And in my opinion, with IPv6 Enhanced, the sky's the limit. It will definitely unleash capabilities that will definitely add a lot of value to the existing ambitions that are there when it comes to 5G SA use cases and the various use cases that are expected as a result of this ecosystem. And that brings me to the end of my presentation. Thank you very much for listening.
Thank you, Ali. Now we are happy also to hear again from Dr. Latif, because we are very glad to announce that now Do is joining the IPE organization. And then the occasion we'll hear again from Latif Ladid, chair of ETSI, ISG, IPE, and then Dr. Will Louis, vice chair, who will join us live. Now we'll start with a pre-recorded video from Latif.
This is Latif. I'm doing this video from the airport in New York. Sorry about the ecosystem here, it is pretty loud. So I'm very pleased to hear that the ITC Do is an outstanding operator in the UAE and has built the best 5G network in the UAE. over the past 2 years, providing good services to consumers, enterprise users through 5G business innovation to enterprise scenarios. Do is providing and committed to providing users with an excellent experience through the integrated innovation of IPE and 5G. At the 2022 MWC, Do CTO, Mr. Salim and myself had an in-depth discussion on joining the IPE organization. Today, Mr. Ali Al-Waladi, the head of the technology service enablement of Do, will deliver a speech titled EITC, Do IPv6 enablement and future prospects. At the same time, on behalf of the IPE organization, I warmly welcome the UAE IETC Do to join the IPE organization. I hope we'll have an in-depth communication and progress in technology evolution and innovation cooperation in the future. Now I'll pass the stage to Dr. Will Yu, Vice President of the IPE, who will confer the certificate of appreciation to the ITC Do. Thank you.
Now it's you, Dr. Will.
Yeah, hello everyone. This is Will Liu, the Vice Chairman of IPE. So as you can see from my screen, that as our Chairman Latif is now in his trip to Latin America, and he just took the video you saw in his transit in New York. So sorry for the noise background. It's my honor, it's my great honor to grant this certificate of IPE to EITC Do. As a leading operator in UAE, the participation from Do will provide great experience, and I'm sure that we will have more and more grateful cooperation in the future. And thank you and welcome.
Thank you, Dr. Will. And just I would say congratulations to Do also. So Ali, you pass the congratulations also to your CTO, my friend Salim Leblouchi as well.
We'll certainly do, and thank you very much, Professor, and thank you, Will. This is truly highly appreciated, and of course, what we hope is that to add to this knowledge of body and the amazing job that you guys are doing.
Thank you.
Okay, now we will continue the session. We still have one speaker. Okay, now we will have also we'll hear from Carsten Rosenhoven, Managing Director and Co-founder of EANTC AG, through a pre-recorded video again.
Hello, my name is Carsten Rosenhövel. I am CTO and co-founder of EANTC, the European Advanced Networking Test Center in Berlin, Germany. I'm really sorry and apologize that I cannot be in person with you this time. Maybe next time, but for now, I'm very happy that I got the opportunity to present the latest SRv6 industry update to you. At EANTC, we are running multi-vendor interoperability test events as we are an independent test lab. We're focusing transport technologies and application technologies in the fixed and mobile sector. We're completely vendor neutral, and as such, we are always inviting all the vendors to participate in our multi-vendor interoperability events. This year, in the springtime, we hosted one with 14 participating vendors with 40 different device types. We had a total of 5 months of preparation, during which we prepared the test planning, agreed on the coverage of the individual test scenarios and so on, which culminated in an intense 2-week hot staging carried out in Berlin at our premises, at our lab, and also hybrid with remote participants during the COVID times. After these 2 weeks, we had more than 600 multi-vendor test result combinations, a really humongous number, which we then processed into a joint report of more than 40 pages. Our technical goals were to advance the multi-vendor interoperability of transport network solutions across the whole telco industry. Of course, we went far beyond SRv6 coverage, which is the main topic today, but we also covered SDN, segment routing, all of the management orchestration technologies with NetConf and different YANG models. We covered EVPN services, policies, flexible algorithms, for example, which are very important in 5G slicing, and also clock synchronization. The vendors who participated came from all of these different backgrounds, so the range was quite broad, from core through aggregation router vendors, data center and edge equipment vendors to test tool manufacturers. If you look at the end-to-end test scenario with all of the different groups of devices, you can see that there is a segment routing MPLS-based area in the top right, the light green area. The SRv6 area in the center right, dark green, is what we're really looking at today. And on the left-hand side, we have a big network that is VXLAN segment routing based. So all of these interoperated first within themselves, and then we built an end-to-end network to support multiple different types of demonstrations. If we look a little bit closer to the SRv6 scenario, we can see that there are quite a number of vendors participating, which is already a very good sign. So the vendor community has increased quite a bit in SRv6 over the last few years. It started a little bit slow, but now recently we're seeing more and more uptake from all of the vendors in the industry. And specifically, we see deeper involvement in the more advanced SRv6 scenarios. So the technology is really gaining traction. And we were fortunate to set up this testbed here with a strong support from Nokia, from Juniper, from Huawei, ZTE, and from Arcus, and also from the test equipment manufacturers Spirent and Keysight. What are the building blocks for the success of SRv6? Of course, first there need to be the routing basics. It's important that the global routing table and the route summarization is supported. But then, of course, there need to be some service support. Layer 3 VPNs and EVPNs need to be run over SRv6. The next topic for service providers is really important, the resiliency and high availability. So all of the core and edge availability functions need to be supported that people are used to from the MPLS area. That's, of course, the TI-LFA, topology independent loop-free alternate for network path and node failover. It's seamless BFD to detect failures in the network quickly, and it's also multi-homing at the edge. Furthermore, of course, SRv6 is not going to substitute other types of transport networks completely anytime soon, and maybe that's also not even the goal. So for this reason, interworking is very important, interworking with MPLS, interworking with routed and with switched EVPNs over segment routing MPLS and over VXLAN. And finally, the constraint-based routing is kind of the new big thing to really automate slicing and quality-based routing and guarantee some constraints. Actually, a very old topic, but with a new type of solution. So going into a little bit more details, of course, we started with the VPN services over SRv6. We tested the traditional layer 3 VPN services, which are still required in many deployment scenarios. We tested the BGP control plane. We tested the data plane with SRv6, obviously, and 7 vendors, all of them participated in this test area. So the basic services are supported by everybody for the layer 3 VPN and also for the VPWS, like point-to-point services, which 6 vendors participated in. In the high availability area, we validated topology independent loop-free alternate, the TI-LFA standardized solution, with 4 vendors in total. The testing in this area always takes a little more time because each of the implementations needs to take the role of the PLR, the point of local repair, in turns. So we made sure that in all of the combinations, we really swapped the role of the PLR so that each of the implementations confirmed correct implementation in all of the roles. The great news is that the failover times were always met in any combination by any of the PLRs. They were always within less than 30 milliseconds, which is certainly better than required by all of the normal service provider use case scenarios. In one case, we even went down to 2 milliseconds failover time, repair time to be more precise, and this was really an outstanding result. Of course, SRv6 is not going to take over the whole world, although some vendors wish it would. But for the time being, there will always be an interworking scenario required. There will usually be one part of the network which is legacy MPLS or which has other technologies of segment routing over MPLS or over VXLAN, and another part of the network that will have been migrated to SRv6. This migration is a challenge, but it's also a necessity. We validated both of these scenarios. First, a brownfield legacy MPLS environment. I should be careful. I mean, obviously MPLS is still working great, but the interworking between these two domains is always critical, and it's important not to just fall back onto a routed IP-only environment. So we tested the gateway functions which were implemented by 4 of the participating vendors. They need to pop an MPLS label, check the target prefix, and then push the SRv6 header. So this way, native IP routing is avoided. In the second scenario, we validated that there could be different segment routing domains connected with each other. And in our case, we integrated with a segment routing domain based on MPLS stack. And only 2 vendors participated here. The scenario is a little more advanced and a little more complex to implement, to convert the labels, to map the service prefixes, and to use appropriate attributes so that there won't be any loops. Because that's one of the major points. If there is no IP routing involved, of course, it could end up with an endless loop of transport networks, and this needs to be avoided by a special attribute provided in the technology. One of the really great advances in this year's event was the use of FlexAlgo. FlexAlgo has actually been around for 2 years already as an early draft in the Internet Engineering Task Force, in the standardization body for the Internet. But only this year, a number of vendors took up on the implementation. FlexAlgo allows to provide constraint-based routing by using different types of means, traffic engineering focuses, delay constraints, or other administrative groups. We actually tested 4 of these different FlexAlgo groups, and we validated, once we configured everything, that the route calculation in the SRv6 domain was correctly following these groups. So for a service that is delay sensitive, of course, the correct algorithm should be taken, paths that are actually allowing delay sensitive traffic, and so on and so on. So really great to see these different vendors, Juniper, Nokia, and Huawei, implement the technology in an interoperable, multi-vendor ready way. So from the conclusion, I think generally speaking, SRv6 is on a great path. It's on a slope towards productivity. There are already reports of the first productive service provider networks out there. And definitely the technology is becoming more and more complete and more aligned with the other implementations of segment routing over MPLS or VXLAN. The ecosystem continues to grow so that more router vendors are supporting it, which also means in RFPs there is more choice and there are also more ways to expand the network with different vendor integration. The technology support is stable and it's extensive, becoming more extensive, as we have seen in this year's interoperability event, with all of these aspects of not only the VPN services, which are the basics of course, but also the migration and integration with MPLS and segment routing MPLS, high availability solutions, and constraint-based routing using FlexAlgo, which is specifically required for 5G services. Of course, the footnote is in our interoperability events, we intentionally only focus on functional testing. So we never do any kind of bake-off. The intent in these multi-vendor interoperability events is to really focus on everything that's supported on the same level by each of the participating vendors. The areas that we still have to focus on in the future to close the gap to production networks are certainly performance and scalability, also the energy efficiency and security aspects. These are important building blocks which remain yet to be tested at a broader scale. But in any case, overall, I'm happy to confirm that SRv6 is ready for prime time now. Thank you very much for your attendance. It has been a pleasure. And I hope you will continue to be interested in our series of multi-vendor interoperability events. We're planning the next one for specific front-haul transport in the fall time together in our joint lab with Deutsche Telekom and other partners, the I14Y lab in Berlin. And in spring next year, of course, we'll do our big transport network interoperability event again as well. Thank you.
Thank you, Carson. Now we'll go for the poll now. I will launch the poll. So I encourage everyone to check the poll, answer the questions. Meanwhile, we will start with our Q&A. Okay, I will check if you want to answer the question, please you go ahead. We'll start. We have one question here.
I think the first two question is for me.
Yes, you can go ahead.
Yeah, I'll go answer them. So the first question is, I can see the study update stop at 2020 only. So this is the study that we conduct last year. And so the data is that we conducted the study in 2021, but the data is 2020. That's because that we can have universal full year data at the point of 2020. And we will probably update this study. So the next quarter, I think. So the last year, the paper, the web paper was published in the fourth quarter. So we are preparing to update the data, and you can keep in touch and to see whether there will be an update. So that's the first one. And the second question is asking about the source of the revenue impact because of IPv6. So for the revenue impact, we actually constructed a model ourselves to calculate the actual impact for each industry. And the model is consists of three parts. So the first one is improved security. The second one is increased efficiency. And the third one is empowered innovation. So for improved security, we actually calculated for each industry, the cost reduction due to malicious attack, the cost reduction due to system failure, and the cost reduction due to human error. And for the increased efficiency, we calculated the efficiency improved due to NAT removal. And for empowered innovation, we calculated value created via 5G, IoT, and cloud because of IPv6 enablement. So for each of them, we constructed our own model. So there is no actual single source for that, but Roland, Berger, and together with Huawei, we conduct our own study. And we, for each of the item, we use sources around the world. Yeah. So I think that
thank you, Xiaohong. We have a question about for MBB, what you assign the UE 64 or 56. Anyone would like to answer this one? For mobile broadband, any special you can assign? Who will take the answer to answer this one? Maybe Ali or Omar, they should answer, I guess.
Yes. I think we have deployed the same /64 for both. For
okay.
and CP as well.
Okay, very good. Thank you very much. Then I will go to the other questions. Okay, we will have for 4G, 5G routers. You assign it also for the routers also, so MBB, 4G, 5G, you assign the same, yes?
Yes.
Okay, so already we answered, I mean for IPv6, of course. Then we have another question from Majid Al-Ashi. Okay, dear Ali, okay, but no questions, I don't know. Okay, then from Omar Al-Mheiri, can we know now when IPv6 will be mandatory in Saudi Arabia? Unfortunately, we don't have the regulator from Saudi Arabia with us to answer this question. Maybe ITU can tell us, Dr. Bilal, if you can answer on their behalf. Dr. Bilal?
Yes, Toni, could you please repeat the question?
Yeah, it's about if it's a mandatory in the IPv6 will be in Saudi Arabia soon. Any date, anything?
Well, I think Saudi Arabia, as we have seen in the presentation, is among the first countries, member states, in terms of penetration of IPv6, close to 50% use of IPv6. So it's clear there has been clear policy direction and implementation throughout the kingdom to move from V4 to V6.
Oh, thank you, Dr. Bilal. Last two questions are for Do and Etisalat. Okay, mandatory. Okay, clear. How can we plan properly as mobile operators set the range of IP address we need to buy or reverse? This is, I guess, in the presentation, but also anyone can do some elaborate more on this about the limit of IPv address and how much we can forecast. Dr. Meshal, as the regulator, maybe Meshal, sorry, Engineer Meshal, if you can answer what the expectation was the forecast for the IPv6 address.
Thank you, Mr. Toni. Actually, we don't have an accurate 100% number, but as per my understanding, based on the presented information from a low utilization perspective, organizations are willing to request and allocate a subnet of IPv6, but the adoption and the usage of the IPv6 cannot actually provide us with a real number of what is the expected total number of IPv6 to be used within the country. So this is something which we are working on now to understand the need of the market, which will be more clearer for us actually during the or let's say after the campaigns which we are working on currently from a training perspective for the experts, as well as the awareness campaigns to the end users, as highlighted by my colleagues from Etisalat and Do, that there are some unmanaged CPEs. Most of them are with people who might have some technical background. So they just would like to go with whatever existing with them based on the performance that they are having, and they don't want actually to go and do any kind of changes since the setup is working fine. They are not facing any issue. So back to the question, there is no 100% accurate number. These need to be studied more based on the awareness campaigns and like action taken by end users and society here within the UAE.
Well, thank you very much. Do you have some number, Xiaohong, for this, maybe for the forecast globally as you're working in a research company? You are muted. You are muted.
Sorry, I don't think I have this number at hand right now.
Yeah, it's fine. It's fine. It's anyway. It's a forecast. Thank you very much. Yes, Bilal.
Yeah, perhaps, I mean, in terms of the forecast and the need of the numbers, the good news with IPv6 is that there is almost no limit in terms of the trillion
From technology side, you mean, Dr. Bilal?
From the IPv6 address space.
Okay.
It's unlimited, so there is no constraint in terms of allocation of IPv6 addresses to countries or from countries to the operators and users. We don't have the same scarcity as we used to have with IPv4. We don't have that problem in IPv6. We have almost infinite number of IPv6 addresses.
Thank you. Now we have a question. Please advise the recommended IPv6 allocation for CPE or FPP. This is maybe Dr. Will, you should answer on this from the IPE. Dr. Will, you still with us?
I'm sorry, I was just having a call. So what question do you want me to answer?
The question is very important, I guess, from your perspective, because please advise the recommended IPv6 allocation per CPE for FBB.
Of course. So actually in IPE aliens, we have several documents about, this kind of IPv6 deployment practice. So basically, in this document, we have end-to-end deployment practice, including, like what you said, the CPE part, also for the IP transport, and also for the core network. So it's actually an end-to-end best practice now. And given the time, I will not go into the deep, but if you are interested, we can share all the materials to you and for your, for the guidance for you to deploy it.
Okay, thank you. Then we'll move to other question because we have many questions and we have limited time. Sorry, we cannot answer all the question now. From Amr Hilmi, MBB UE should have 64 and preferably 56 and mobile routers FBB. Okay, he's answering a question on your behalf. Then we have in some scenario, okay, it's like using full proxy technique, which we use to hide the source IP as security method. There is a special method in IPv6. I don't know if Dr. Will also you can answer maybe this. This is very technical for this. In some scenarios, like using full proxy technique, which we use to hide the source IP as security method. Is there a similar method in IPv6?
If you are talking about for the end devices, I mean IPv6 prefix to assign to the end devices to identify like the users and identify the their which user is using these devices. There are some discussions in IETF. I still remember that Facebook actually proposed some draft on this site, but until now we didn't have much progress on this trend because, like what you said, it's related to the user privacy issue, and we need to think about the flexibility versus the user privacy issue. So I think this may be a little bit complicated to explain at this moment.
Yeah, as well, I said very technical. It's better for you to answer. I cannot. No one, I guess, can answer. Let me just read end the poll and reading the poll with you. The poll result with you. Okay. So now, as we ended the poll, we'll go to the first question of the poll. It's, have your company migrated to IPv6? Yes, 21%. In progress, 54%. No, it's 25%, which means we are really doing the moving is between progress and yes, we have even 70%, 75%. For the second question, the poll, how you're contributing to IPv6 deployment? Providing the technology is 52%, drafting pertinent strategy and policies 29%, improving R&D 19%, which is good also. Question number 3 on the poll, how are the benefits of IPv6 Enhanced reflect the most? Economically, we say 15%, technologically 75%, professionally 10%. I guess the technology will have an impact on everything in our time. The last one in the poll, is the Middle East leading the IPv6 Enhanced compared to other regions? 23% they said yes, relatively 67% yes, and no is 10%. I guess we know in most of the presentations that Middle East is leading with being UAE and Saudi on the top of even within the global numbers. We see that the Middle East between UAE and Saudi, they're really leading IPv6 and then in the Middle East. So I guess the IPv6 technology will be soon indirectly will be mandatory because all the new vendors, are going to also to have this technology. I would like to thank you all for your really for the details, for your time, for this presentation. You give us really it's good webinar today. I received lot of even comments on my WhatsApp now about this session. So really, I would like deeply appreciate. At Telecom, we will have full coverage next week about all this. Okay, with all your presentation, I will be in contact with you all also by email. Thank you for your time. Thank you for your presentation, for the details, and to have you with us today. Thank you very much. Thank you.
Thank you, Toni.
Thank you so much.
Thank you.
Bye bye.
Thank you. Bye.
Bye bye. Thanks.